Hello, CodeDay Labs mentors. My name is Tyler Menezes. I'm the executive director of the nonprofit CodeDay, and allow me to be the very first to say thank you so much for devoting your time and knowledge to the students who are going through this program. This makes such a big impact on the students, and we really couldn't have done it without you, so thank you so much. With that in mind, we're going to try to be respectful of your time and just keep things today to the high level, important information you need to know about being a mentor. We will be sending out information every week, and you're always welcome to send an email or give us a phone call if you do have any questions as well. So we're going to try to keep this to the high level information today. So let's get started by talking a little bit about the students who you are going to be working with. Now, you're going to be working with only 2 to 4 students, so the specific students you get might vary, but in general, most of the students that we have are college sophomores. We have some juniors and a smaller number of seniors. All of them are going to be at least college level intro CS experience level. Some of them will have more experience. Very small number of them have done projects, but which classes they've taken and how many classes they've taken after the intro level will vary a little bit by student. But baseline, they'll all be intro level, and most of them will be pretty newer. Now, almost all of these students attend what are called non-target schools. And what that means is it's schools that recruiters and tech companies don't consider big enough that they're not really putting in any effort to recruit students from this school. So that's one of the big reasons why we started this program, is to try to get these students a little bit more of help them get their foot in the door a little bit more in the tech industry. So all of these students, or most of these students, are going to be from these non-target schools. A lot of the students that you're going to see are going to be working to pay for school. So just be aware their time may vary a little bit from week to week. If it gets too low, there is a way to let us know, but it may vary a little bit. And also, there's going to be a pretty diverse pool of students that you're going to be working with here, both in terms of gender, ethnicity, even age range. A lot of these students are older than you might be used to for college students. So now let's talk a little bit about what our goals for the program are. One of the big ones is that we want students to learn to work independently. Most of these students are great technically. They have the technical skills they need, but they're not at a point where they know how to do a project independently. When they're given, step-by-step instructions from their school, they're able to follow them, but they don't necessarily have the ability to do a project on their own. We're hoping to get these students some practical experience early, because usually the way students learn to work on projects independently is from something like an internship or some other like attending hackathons or things like that. But most of these students are not going to get those sort of experiences until their senior year. And we want to give them that experience earlier because it's a compounding benefit. The earlier they can work independently, the more they can learn independently. We want them to be able to keep working on open source software. This is not as big of a focus for us, and not all the students do, but if they're interested, we want them to gain the skills that they need to work independently without a mentor. And finally, we're helping to help them build a resume, because ultimately we want these students to get a job. Okay, so that's the goals. Let's talk a little bit about what to expect from your team and the format of the program. So we're going to match you with 2 to 4 students and 1 task. The task is going to be from an open source project that we partner with, and we're going to give you just one of them. So the students are going to be collaborating together to solve just one task. A lot of pair programming conversations. They're not going to be working independently to solve it. They are going to be working collaboratively. That's a really common question that we get. You as a mentor are going to be responsible for 1 weekly mentored meeting. Just 1 meeting per week with you as a mentor. The students are also going to be working independently in work sessions, as well as with somewhere around 6 hours a week of totally independent work. So they're going to be working much more than you to actually make progress on this. You're only committing 1 hour a week to meet with them, but they should be making a lot of progress outside of those meetings because they're committing so much more time. Now, I know I mentioned, open source projects, and I think a lot of mentors at this point are thinking, well, what if I don't have experience with open source projects or the project that you assign me to? I want to emphasize that there is no familiarity needed with the open source projects. The reason for this is we're trying to teach the students to work independently. And one of the big barriers that they face is a thing that we like to call the expert fallacy. So what happens for a lot of students is they spend so much time, in school in their lifetime that they start to think of, their teachers and their professors and their lecturers as experts. And whenever they have a question, they go and ask, and usually that person knows the answer because the question that they had is something fairly basic. So they start to think of these teachers as experts, right? And they think that when they graduate, they should just know the answer to everything because, when they graduate, that's how you become an expert, right? You graduate and you know the answer to everything. And that's obviously not true. But these students start to feel bad. They feel like they don't know enough, and it reinforces some learned helplessness, right? They're afraid to actually start things because they don't know how to do it. So for you as mentors, the biggest thing that you can contribute is by showing how you approach problem solving, showing how you solve these problems, demonstrating the techniques that a professional in the tech industry uses to figure out where to get started on a problem, how to debug things, how to approach doing some research, and then how to solve the problem. That's what we want from you. And because of that, we're assigning you to open source projects that you don't know anything about. So you're almost like a peer to these students. When they come to you with questions, you're not expected to know the answer. You're expected to use the techniques that you've been given as a professional developer that you've learned over the years to try to figure out the answers too. And we'll talk about this, but the students will have some agenda in mind. They'll have done some research ahead of time. You're not starting from nothing, but they'll come to you with proposals and you won't know the answer, and that's okay because what we're trying to teach the students is how to approach those problems. So it's very important to keep this slide in mind. So one of the biggest things that we're teaching the students is just how to approach a problem. Okay, so format of this program wise, week 1, before the students even meet with you, the week before your planned start date, there are no mentors. The students are going through some onboarding exercises, and later on I'll tell you what they're learning, but just basic information about their project and about working independently. We're trying to give them some techniques before they get started. Week 2 is when they first meet with you, and that first meeting is going to focus on any problems that they're having getting the project built and starting point. Finding what we call a starting point, a place in the code base that the students can just get started. It's not necessarily the right place that they're going to need to make a change, but maybe it's somewhere along the path that the information flows, or a file that's probably in the same directory, something that touches the information that needs to be changed. They're trying to find potential starting points in the code base to start making some changes and trying them out. So that's what the first meeting with you as a mentor is going to focus on. After that, every other week except the last week is going to focus mostly on helping them with specific questions. So they should come to each meeting with some specific questions in mind. And, they're going to be asking you those questions, and you collaboratively with them will look into things and see if you can figure it out. The very last week, as well as helping them finalize anything, we'll also focus on a code review if they do have everything done, or a review of whatever's there. Just looking for basic things, good coding practices. Are the variables well named? Are they using the correct number of tabs or spaces? Things like that. And then finally, if they are done, this is a really great time for you to do some reflection together. Talk about what you achieved, what the real world implications of this are, and do some things like give some feedback on how they're going to put it on their resume. So that's kind of what to expect in terms of each one of these meetings. And the students will come prepared to each one of these meetings with an agenda in mind. So as I mentioned, students will prepare the agendas for the meeting. We're going to give students a template for each one of these meetings. They're going to come in, for example, I said in that first meeting with you is going to focus on starting points. The students will come into that meeting with some potential starting points already brainstormed. And your job as a team will be to talk about their ideas for what those starting points might be and come to a conclusion on which one is the most promising. So each week you will be using an agenda that is driven by the students and collaborating with them to sort of provide feedback on the research that they have already done without you. It's really important. One thing I want to stress with each one of these meetings is provide feedback. If you think that they've done something well, please tell them that they've done something well. Students are really used to this loop of like lecture, homework, test, lecture, homework, test, right? They're always trying to think of things in this mindset because this is the mindset they're used to. And when you're taking a test, if you don't know the answer, you failed the test. So the students oftentimes think the same thing about working with you. If they didn't get the right answer, if they didn't pick the right starting point, or if they didn't come up with the right solution to a problem that they're facing, they feel like they failed. And for, those of us who have been professional developers, we realize that oftentimes failing is part of the process. It's iterative, right? We find the right answer through trying things over and over. So it's important to tell the students that this is okay and to give them positive feedback whenever they're doing something well, so that they know that even though this is very unlike the classes that they've taken and the tests that they're used to, they're still succeeding if they are succeeding. A lot of students actually also think that the lines of code, the number of lines of code that they've written, is their metric of success. Most of the tasks that we assign students in these projects don't require even 1,000 lines of code. In fact, many of them only require a couple of lines of code to be changed. With that in mind, when they're only changing a couple lines of code, but they're used to writing lots of code, again, it can feel like they're failing. So it's really important for you as a mentor to give them that positive feedback and let them know that, yes, figuring out what line of code you want to write is part of the process. And no, you're not expected to get the right answer on the first try. Okay, so I mentioned that some of the students are going to get some training ahead of time, and I wanted to briefly just touch on what training you should expect your students to have coming into working with you. The very first one is we do cover just what is open source software and general etiquette for working on an open source project. So things like, how to leave a comment or things like that. We cover some basics of Get. They've already learned Get in their classes, but just a refresher. They'll probably still have problems, but I've been using Get for 10 years and I still have problems. It's normal, but they should have a basic refresher down. We cover breaking down lines of code. And what that means is when the students see a line of code that they don't understand, they should have some initial techniques to use to try to figure out what that line of code is doing. We talk about breaking down classes and modules. When you have a really big file and you can't even read it all, how do we get a general sense, a general gestalt of what the class does? We talk about finding starting points. When you have this really big code base with potentially thousands of files or more, where do you start? How do you find a place to start? We talk a little bit about building and development versus production. One common mistake that we've seen students make is they install their, let's say they're editing a package, Python package, and they'll just do pip install that package. Well, then there's no way for them to test their changes because they haven't installed a development version versus, production version. So we talk a little bit about that. Finally, we talk a little bit about pair programming. So when the students actually work with each other, what are some techniques for them to sort of collaborate and how that all works? We do have some resources available for the students. One of the big ones is going to be getting their code running. Now, remember I mentioned a lot of these students are from a lower income background and are often working to pay their way through school. Many of them don't have the money to afford a brand new Mac. A lot of them are running on Windows, and that sometimes leads to problems getting code to compile because a lot of our code is only tested on Mac and Linux. So GitHub Codespaces is a really great tool that we provide them. It's a cloud-based IDE. It's backed by a full virtual machine, and they're able to use GitHub Codespaces to run their code, to edit it, all in the cloud in a Linux-like environment. The other alternative that a lot of teams and students might want to use is something called Windows Subsystem for Linux. This is built into any Windows computer. You have to run a command to activate it, but it will allow you to run a full Linux virtual machine inside of your Windows computer, actually with very little overhead. It does some direct kernel level translation. It's really a wonder of engineering, but that's a really great option if they don't want to use Codespaces. Another resource that we provide to students is a Slack. If you have not used Slack before, it's like Microsoft Teams or anything else that's one of those sort of enterprise chat programs. It's a place for the students to work together and collaborate. We will invite you if you want to join the Slack and you want to talk with them throughout this program, you're welcome to. But just to be clear, it is not required at all. It is totally up to you, and it's totally fine if you don't want to join. I will let you know, one of the things that we do exclusively in Slack is we have the students submit updates every 1 to 2 days on what they've been working on, basically just a stand-up style thing. So if you want to see the results of those, you're welcome to join the Slack based on the invite that we give you. And that's pretty much it. That's the basic stuff that you need to know about CodeDay Labs, how to be a mentor, and sort of what to expect. Now, again, there are a lot of meetings that you're going to be having with students, and I'm sure that many of you might be afraid or nervous or just not really sure what to expect from each of those meetings. We will be sending out every week an agenda for the upcoming meetings, so just keep that in mind. We'll be giving you some resources as things go. The students should be driving a lot more of those agendas as well. So you can sort of rely on them so that you don't have to do much preparation, if any, before those meetings. And finally, if you have any questions, we are always available to help. So feel free to reach out. You can send us an email or a phone call if you have talked with a mentor manager before. You're welcome to give them a phone call and just to ask your questions to them. We are always here to help. We're here to troubleshoot any problems that you have with your students. And we'll be keeping a close eye on things to see how things go. So if any students do start to show signs of being, flaky or just not having enough time or other problems that we've seen that are common problems, we'll be reaching out to them as well. Thank you again so much for being a mentor for this. We really appreciate it, and we're really excited to work with you and to see what the students create. About 90% of the students who go through this program do create successfully a pull request and open it on their assigned open source program. Somewhere around 40 to 50% continue to make more pull requests afterward. And the number of students who get internships that go through this program compared to their peers is almost double. So the impact that you're going to make as a mentor, we know is going to be really great and hopefully will be really satisfying to you. Thank you so much, and we really look forward to working with you.